Okay, everybody. Good morning to you, and good morning to those people who are at home. We got at least three people. I'm not gonna, say your name for this because I might make this particular video public because we're gonna go over some things. I'm gonna go to my website here, okay, and I'm gonna share with you where this is. I went through. This is applications of law of sines and law of cosines. So I did a whole application. I should have numbered it like 1, 2, blah, 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 right? And I'll put it in the chat there. And I'm just going to say to you guys, we're going to try to work with these applications today. But I don't want you guys to be afraid of word problems. And historically, people have been. I remember when I was a student, I was terrified of word problems, It was like, oh my God, there's this problems with words. I have enough problems doing the ones without words. You guys know what I'm saying? And that's how I thought. So, anyway, let's take a look. Now, remember, we went over yesterday some geometry. And really trigonometry, because we're looking at law of cosines, right? So we're looking at some geometry yesterday, and that's a pretty good thing to consider, right? Because that's really the key. And sometimes you're lucky, and you're lucky in the sense that they'll give you a picture. You go, oh my God, I wonder, that was great. Now look at what they're saying here. A path of a satellite orbiting the Earth causes it to pass directly over two satellite stations called A and B. Now, this is what they're saying here. If I go to my version, right? So here's your A and here's your B. A, B. Okay, now they say the path orbiting the Earth causes it directly to pass over two. So you pass directly over both of them. And that's why, and if you said, well, what's the path? Well, they didn't say this to you. But the path is known as a horizontal. Okay? So that horizontal, so it passed directly over the two, and they're called A and B. And then they're saying how far apart are they? They're saying they're what? This distance is what? 65 miles. Okay? Now, when they say the satellite is on one side of two stations, so it's simply to the left of both of these. The angle of elevations are, now notice what they say here. They are what? 70 degrees and 80 degrees respectively. Right? So it's just saying it's on the other side of both of them. And then you start to say, well, how do I figure out which is 70, which is 80, right? And then how do I know where they go? Well, they actually told us it's right here because they drew the picture. But that should make sense because they're talking about what? Angle of what? Elevation. And an elevation is like an eyeball looking at an object on the ground, right? It's elevated. So that makes a lot of sense. And the good news is they gave us a nice, pretty, what? Picture. Okay, you guys okay with that? Here's the picture. Oh, nice. So, okay, what's the first question? How far apart is the satellite? Remember, this is where the satellite is. It's right here. They even told us. I just put a star for satellite. How far apart is the satellite from station A? Now, I'm going to use a letter here again. I'm going to use that letter X because I used that yesterday. So what they're asking us for today here is this distance. Okay? Now, remember something that's vitally important here. That's the distance from the satellite from station A, right? Here's A, and then here's satellite, right? Now, you can call that distance, you could call that X, you could call that what you want. But that's what we have to determine. Now, I make the claim again. Here's my claim. We did this actually yesterday, if you've seen your notes. You see, yesterday I didn't put the words, but this is angle, side, what? Angle. Yeah. How do I know it's angle, side, angle? Because you might say, Mr. Judge, wait a minute. We got to have a triangle, first of all. We have an angle here, right? We have a side here. What does that mean right here? How do I know that angle? That angle measures how much? What does that measure? Anybody know? What does that angle measure? That should be 100 degrees. How do I know it's 100 degrees? 180 minus the 80. Aren't these supplementary angles? So you guys remember why we did the geometry review? We did supplementary angles. And so now here, this measures what? 100 degrees. So what do you have now? What is this? Angle, side, what? Angle. So how would you handle this? Right? How do you guys handle that? Do you guys remember? Law of what? Sines. Remember that mode? Angle, side, angle? And you say, oh, this, we did that here. I did it over here, some of the work there. Law of sines. And you go, okay, well, how do we handle this in terms of law of sines? You guys remember? You got to get that third angle first, right? 180 minus 100 minus 70 degrees. What does that measure? It's 10 degrees. So what do we know? Sine of 10 degrees over 65. Is that true? This portion is going to equal what? Sine of 70 degrees over x. So if we solve for x, what does x equal? Do you guys remember? X is going to be what? 65 sine 70 degrees divided by sine of 10 degrees. Is that right? Okay, so we're going to have to wake up the TI. Say, let's wake up that TI. I know you look at all this and go, oh my God, there's a lot going on there, right? But does it make sense, some things that we were working on? That's the idea. And remember, when do you guys want to practice this stuff? Not the night before. You want to practice it when? Now. That's key. So we say, okay, 65 sine 70 divided by sine of what? 10 degrees. Right? What do you get now? Let's go to the nearest tenths again. 351.7 miles, I guess. Is that right? 351.7. And that's what we just found. Okay? 351.7 miles. There you are. So that's how we found that distance. You say, oh, okay, that's interesting. So stop and think about what we did yesterday, right? I did the same kind of question yesterday, but without the words. And the reason I do that is to gently, Gently approach the subject, I should say that. right? Now, what's the next question that they're asking in B, right? This is a X. What's the next question? What is the altitude of the satellite above the ground? What's the altitude of the satellite above the ground? Altitude, ladies and gentlemen, is right up in here. I'm going to erase this. This is the altitude. It is a line that's perpendicular to the ground. And this is maybe we say height or A. I call it height. So this is the altitude, okay? Now, notice what they did. They actually gave us again, the same kind of picture we worked on yesterday. And then what I have down here is a picture of that, so you guys can see here now, right? So what do we know here, ladies and gentlemen, about this situation here? Focus again now on what? On the right triangle. You see, what did we just find here? Wasn't this what? The hypotenuse of it? And that's the idea. We just found 351 point what? 7, and that's miles. So far, so good? And all we need, if we are in a right triangle situation, here it is. 90 degrees, right? What's your definition? Right? You have hypotenuse, you have opposite. Which trig ratio do you use? Sine. So you have sine of 80 degrees, by definition, is h over 351.7. Solve for h. You say, what is h? It's 351.7 sine of what? 80 degrees. $351.7 sine what? 80 degrees. What is that altitude? What is h? 346 point what? 4. And there you go. What do you guys think? Easy breezy lemon squeezy? It's exactly the same as what we did yesterday. That's my point. But instead of giving it to you guys all at one shot, right? Like I used to have to with my daughter, I wanted her to eat vegetables. You know what I had to do? I had to, like peas, for example. I had to sneak the peas in the mashed potatoes. You guys know what I mean? So that's kind of what I was doing yesterday. Sneaking the peas, the geometry in the mashed potatoes. So this is exactly what we seen yesterday is what I'm saying to you. And that's why I mentioned, I said, maybe I should do like just a pure geometry kind of, worksheet as that, intermediary. Anyway, look at all that space we have here. We should have used that. And we didn't do, I think we did this one yesterday too. Okay, you guys remember that? We did this one yesterday too, but this is called a flight of a plane. The difference between this question and the last question is what? Here's a big difference. A and B and the plane, well, the plane is in the middle of what? A and B. You guys okay with that? This question, the prior example, it was a satellite. It doesn't matter, satellite or plane. And that one was on the opposite side of both. So compare and contrast, right? So let's compare and contrast. This time, what's the deal? you have this situation. So if this is 35 degrees, I know, and I'm going to color coordinate that. That's 35. This is 46 degrees. What's this? 46 degrees. And then the distance here is 8. So they're saying a pilot is flying over a straight highway. Now, they don't say this stuff, but what they mean is you need a horizontal and you need a straight. What they mean by straight is that these lines are parallel. But they don't tell you that, okay? They don't say that to you. But that's what's happening. That's what they intend. So don't get nervous. They go, what do you mean? A pilot flies over a straight highway? That's what they mean. He determines the angles of depression. Why is it an angle of depression? Because from the pilot's perspective, these angles right here, it's a pilot perspective angle. To two posts 8 miles apart is this. What is the distance of the plane from point A? So again, what are they asking? And I'll use X or I'll use D. How about that? D for distance, because they say, what is the distance of the plane from point what? A. Now, what's nice, because they're saying these are 8 miles apart, you know what's nice? This is angle, side, angle. And you say, why? Angle, side, angle. All right, you guys okay with that? So how do we handle that? You guys know? You say, remember, law of sines again. This is what we also did. And so you get this angle. Isn't that 180 minus what? 35 minus 46. Is that right? So in the calculator, we say what? 180 minus what? 35 minus 46. And that is 99 degrees. Okay? So we found that angle. Remember, this is how we start solving a triangle for law of sines here. Easy breezy, lemon squeezy. And so what you guys see is exactly what I did to start. This is the geometry, ladies and gentlemen. This is the without the words. Okay? All right. So this is a nice situation. This is going to be pretty simple. You say, how is that simple? Well, do you guys remember, what does law of sines say? Sine of 35 degrees over D. Sine of 99 degrees over what? 8. Cross multiply. What do you get? What is D? Yeah, so we have going to be 8. Sine of 35 degrees is going to be over eventually what? Sine of 99 degrees. Do the algebra. Okay, do the algebra on that one. Now let's see what D becomes. Okay, we're going to have what? 8 sine 35 divided by sine 99. And what do you get? What is D going to be approximately? D is what? 4.6. I don't know. I think it's in miles. So, yeah. Yeah. Oh, it's in the calculator? You want to see the calculator? Okay. Oh, I'm sorry. I'm sorry. You can't see that. Yeah. Okay. I get it. I get it. You want to see this. So we go here. Thank you. Thank you. We found an error. This is what? Thank you. Okay. We found an error. Good job. Somebody awake. Because I'm not awake. So that's going to change things. Right? So D, this is now going to be 46. Okay? So the observation was, hey, that's 35 and 46. And you're right. Thank you so much. Okay, so that's yet another thing I got to do when I get home. All right. And that's going to change our answer, by the way. So we're going to get rid of it. We're going to go back to the calculator. And we say what? 8 sine what? 46 divided by sine of 99. 5.8. There it is, 5.8 miles. So there's our D. Okay. So, okay, we answered that first question. And again, excuse me, what do you think they're going to ask for? Find the what? The elevation or the altitude of the, not the place, of the what? Plane. Oh, a typo. Plane. So they're going to want the altitude again. Okay. So if we go back to this picture, maybe I can draw just a straight line, hopefully. H is the altitude. What do you guys want to focus on? The right what? The left right triangle. Okay, you guys okay with that? You guys see what I'm saying? So you're going to use again which right triangle ratio? Which trig ratio? Do you guys want to tell me? Sine, cosine, or tangent? How do you know it's sine? Sine 35 degrees is going to be what? Opposite over what? Hypotenuse. Let me put it over here. So what is H going to be? 5.8 sine 35 degrees. What do you think we get for H? .8 sine of what? 35 degrees. H is going to be 3 point what? 3.3 miles. Okay, just like we did yesterday. Okay, just like you did yesterday. So homework on right triangles and homework on law of sines is applied in this example too. So we did that one yesterday. Is that right? You guys know what I'm saying? All right. And well, this one is a height of a tree question. Okay, so what are they saying in this one? They say a tree on a hillside casts a shadow 200 feet down the hill. So that first sentence, what do they mean? Right? You have the sun, and of course you guys know sun rays are what? These are sun rays. This is a sun ray. So far so good? And what happens with that tree? Doesn't it block the sun rays too? Because it's really thought of as all these sun rays are really coming. So the tree is blocking sun rays. What does that mean? It casts a shadow. And this is where the shadow lives, okay? Maybe that's too big of a shadow. I don't know. But what do they say? It's 200 feet downhill. So this whole distance is 200 what? Feet for that shadow. So as you guys can see, we're starting to create a what? A triangle there, right? So, okay, let's read some more, right? So here's what they say. They give you something called an angle of inclination. What do you think that is? It's the angle of incline on the hillside. So this is a hillside angle of incline, and it measures what? 25 degrees to the horizontal of the angle of elevation to the sun. What does it say? The angle of inclination on the hillside measures 25 degrees to the horizontal. So you might say, what horizontal? Right? So what they're saying is the angle of the hill is what? 25 degrees right there. There's a horizontal here. So the only way they can measure that is if they have a horizontal. So you go, all these highlighters, right? Wow, they have a horizontal there, right? So, okay, let's get rid of that. Now, what else do they say? The angle of elevation to the sun measures 55 degrees. So angle of elevation to the sun, meaning you have an eyeball right here. And you have this horizontal because remember what the definition of an angle of elevation is. You need a what again? The horizontal to define the angle. Without it, here's the object. So what they're now saying, I'm going to change that color, is this should measure 52 degrees. Okay, because that's where your eyeball is. It's an angle of elevation. Okay, things are coming into play here, right? So why do I say, if we focus on this, why is this going to be angle, side, angle again? Why is this going to be a law of what? Science question. You might say, I don't see why. Well, here's a big hint to you. I know this side is 200, don't I? I also know this angle right in here. How do I know that angle? I take the 52 degrees and I subtract the what? You say, how do you know that, right? This measures 25 degrees. Oops, sorry. Let me go back. Right? How do we know this here? This whole thing is what? That doesn't measure. This measures what? 25 right in here. You say, how do we know? Again, you have a what? It's a transversal. So if I subtract now 52 minus 25, what does that give you? What's the difference? You guys know? Is that 27 degrees? I'm not awake. I haven't drank my coffee. So this angle here is 27 degrees. Let's try to write that nicer. Okay, you guys okay with that? Now, if you look further down here, you go, well, I messed up on that one. There's 27 degrees here. Okay? Yeah. 55. There it is. That's why it's wrong. This picture should be what? Got another one. I'm glad we're going over it. That's 55 degrees. So if you take that 55 degrees, that's why you get the what? 30-degree angle there. Okay, you guys okay with that? That's where 30 degrees comes from. Good. All right. But then you say again, what's this angle? And I'm going to put it in gold now here, right? We want to know what this angle, I want to know what this angle is here. I got news for you. This measures what? 90. So it's going to be 90 plus, okay, 90 plus an angle here. What is that little angle? If you guys see it there, do you guys know what that would be? What angle is this? Anybody know? That angle? How do I get that angle? Yep. How do I get it? Do you guys know? Isn't that 25 degrees? Why do we know that this is 25 degrees? There's two reasons. Okay, let me get rid of some of these things. You guys know why I know that angle is 25 degrees? I can say here, this angle and that angle, aren't they vertical angles? And I also say, because you have a transversal, isn't that 25? So that makes this 25. So what do we get for 90 plus? Right, we're going to get this angle here in gold, and that's going to be 90 plus 25 now, okay? So this is what makes this a what? Law of science question. And you guys know by now, what's the first step? Get the third angle. 180 minus 30 minus 115 degrees. What do you end up with? Is that 35 degrees? There you go. There it is. Can I very easily get H now? What do you guys think? Yeah. Remember, this is going to be a law of what again? Law of sines. So I just kind of want to let people know law of sines there. And let's see what you guys get here. This is going to be sine of what? 30 degrees over H is sine of 35 degrees over 200. So you say, how do we solve for h? Cross what? Multiply. And I apologize. You guys can't see a word I'm doing. Apologize. So let me do this. Too many colors. Sine of 30 over h. This is what we have here. Right? Will be sine of 35 over that 200. All right, you guys okay with that? Now, let's get the h. H will be what? 200 sine 30 divided by sine of 35 degrees. So let's get that h, ladies and gentlemen. H, and let's see. Calculator. 200 sine 30 divided by sine of what? 35. And what do you end up getting here? 174 point what? And ladies and gentlemen, feet, not miles. That's a big tree. It's probably not on planet Earth. They forgot to tell you that on some other planet, you know. It's a big planet if it was miles, but anyway, that's 174.3 feet, and that's kind of, you know, this is how we apply the work with transversals and vertical angles. So, I mean, we went over that idea. Remember that first week, what a vertical angle is, and, you know, and the transversal. That's very important detail in some of these kind of questions. Now, you know, you want to be careful because a lot of times people think, oh, where do I see some of these questions? Well, when you in your major, when you take some of these science classes, you know, you're going to see these questions. See what I'm saying? And then you say, and then you're going to, you know, when you take those classes, they'll say to you, hey, who'd you have for trigonometry? You go, Mr. Snodgrass. Is that right? There it is, ladies and gentlemen. Here's another very important question. That's law of what? Sines again. So you got an observer at P and Q are located on the side of a hill. Here they are. Well, they changed the letter. They should say A and B, right? Now, you say, Mr. Judge, how do you know it's the law of what? Well, some experience. You see that side? What do you think we're going to have to find again? The angles, right? So I want to just remark. Now, what else do they say? Okay, you're looking at the side of a hill that is inclined at 28 degrees to the horizontal. So that's the hill incline. Okay, so this here, the incline of the hill to a horizontal, that's the 28 degrees right in there. Okay. And let's see what else they have. What else are they going to say here? The observer P, so you got an eyeball at P, determines the angle of elevation to the hot air balloon to be 62 degrees. So you go, wait a minute. This is your eyeball. So this is going to measure what? 62 degrees. Right? Because you need a horizontal. Okay, now I'm saying this whole thing measures what? 62 degrees. Okay, because that's how you measure an angle of elevation, right? The horizontal to that line of sight to the object. So the point I'm making here is, what's this difference going to be right in here for the triangle again, as you guys can see? Because you're going to get another, what? Another triangle here. So what do you get? 62 degrees minus 50 degrees. What does this measure? 12 degrees. Okay. Okay, so take a look right in there. That's 12 degrees now. Now, remember here, for the other angle, how do we get this angle now? Anybody know? Because let's kind of think about this, right? What are they going to say here? At that same instant, an observer at Q. Oh, there's another part of information there. Yeah. Up. Sorry, 62 degrees minus 12 degrees. Sorry, I was looking at the number 50 down there. So it's going to be 62 degrees minus what? Minus 28 degrees. Sorry. What's 62 minus 28? Let's get that coffee going. What is it? 34 degrees. Good. Thank you so much. I was looking at this number down here. This is 34 degrees, okay? So there we go, 34. I apologize. Let's get that coffee in us. Take a look. Now, what else do they say? At that same instant, observer at Q measures the angle of elevation to be what? 72 degrees. So at Q, the angle of elevation, remember this, you have to have a horizontal. You do. And it's the line of sight. It's the angle between the horizontal and the object. So this measures what? 72. That's the definition. Okay, because you have an eyeball at Q now, an angle of elevation. Horizontal and what? Object. So how do I get, I'm running out of colors. I could get this angle easily here in pink. What is that going to be in pink? 180 minus 72. And that's going to be 108 degrees, okay? So in pink, we got 108 degrees. Can't even see that. But what's this total angle? Right? This is 108. What is this whole angle here? Anyone want to tell me? It's 108 plus... Okay, this is going to be right here. We're talking this whole angle now. 108 degrees. Because we take that 108, and then we need this little angle here. And that's going to be 28. Is that right? Now you say, how do we know it's 28? Because it's a transversal. So 108 plus 28, ladies and gentlemen. And what does that give you? 136 degrees. So we got 34 degrees, 136 degree. I don't want to look at all of that, do I? 34, we're going to put it right in here. And, I mean, this is accurate, but we need this whole angle. And we found that whole angle to be 136. So again, we have what? angle, side, angle for that triangle to the balloon. But what are they asking? If P is 50 meters downhill from Q, we got that in the picture. Find the distance from Q to the balloon. So what they're asking now, Q is over here. They're asking for that distance. They're going to call that D. So this is my D here. Okay? Angle, what? Side angle. Law of sines. So whenever you have law of sines, always get this what? Third angle. 180 degrees. Minus 34. Minus 136. And this is going to be what? What does that measure? 10 degrees. There it is. So let's begin. What do we have here? Sine of 34 degrees over D. Is that right? What does that equal? Sine of 100 and what? 36. Is that right? Sorry. Sine of 10. Oh no, let's be careful. Yeah, sine of 10. Sine of 10 over what? Over 50. Okay. If you want to see it, this over this. Opposite. Remember that? And then green. It's 50. Make sure it's sine, though. So when you solve for D, what do you guys get for D? 50. Is that sine 34 degrees? Over sine of what? Over sine 10 degrees. $50 sine 34 divided by sine of what? 10. 161. Is that true? And I don't know, is that feet, I guess? Meters? I don't remember. So there you go, ladies and gentlemen, 161 meters here. So that's D. Okay, and then I'm going to say note. What do you think they may want to ask next? I'm going to say, what is the altitude of the, is that a balloon? Yeah, of the balloon. So here we go. I guess they didn't ask that. Sorry. They didn't ask it, but if they did, Yeah, then you don't. Then you actually don't have a right triangle anymore. In all honesty, I think it could still deduce it though. It's on the heel. They didn't ask, but I can see something here. This is going to be, if they say the altitude, it's not a right triangle. They didn't ask for that. It's not a right triangle. Hear me, notebook. It's not a right triangle, notebook. There we go. Right? So you have D. You say, what was D? 161 meters. You have this angle here, 30. What do you have here? The angle is going to be, well, they didn't ask, but you have a whole bunch of, I don't want to, you have a bunch, you're going to have to find this angle here. And you have to find these two angles. I think you're going to have 72 minus 28. Is that right? So this corner will be 72 minus 28. Okay. So I'm at, where's this hill? 72 minus 28 for that corner. And then here, it's going to be 90 plus 28. All right. So this would be 90 degrees plus 28, all because you have these transversals. So what is actually 72 minus 28 here? You guys know what that one is? What's 72 minus 28? So 44 degrees. And then what's this 90 plus 28 degrees? Is that 118? So they didn't ask that question, but, you know, then you have to say, well, what do I have now? What is this? This is what? Is that angle, side? So what do you guys use for angle, side? This again is what? Law of sines. Do you guys know what a big tip-off is? You can get that third angle. 180 minus what? 44 minus 118. What do you guys get there? $18 degrees. Okay, you guys okay with this? So how do we find the answer? What is this? Sine 44 degrees over what? H will be sine 118 degrees over 161. Good. And so now H will be 161 sine 44 over sine 118 degrees. Okay, so let's see what happens in our calculator now. 161 sine 44 divided by sine 118. 126 point what? 7. Was that meters? You guys remember? Meters, good. So I don't know if this is a tall tree again. Seems like it. That's a pretty big tree. Oh, a balloon. Was this a balloon now? Okay, it's a high balloon. Well, that makes more sense. Anyway, like I said, I'm working on that cup of coffee still. I haven't finished it. So, yikes. So as you guys can see, there's going to be a little bit of working with transversals. And you got definitions. This is why important definitions of definition of an angle of elevation, definition of an angle of depression. You always have a horizontal. That horizontal defines things. You can't do it without it. So anyway, and those are the tough questions, I would say to you guys. Those are the hard questions. This is as hard as it'll get using those transversals here. But those are real life questions. Like if you take a surveying course or you take these others, they work with this stuff, ladies and gentlemen. Law of sines and law of cosines. And I highly encourage you guys to get some skills. You go, what do you mean? Yeah, learn this stuff. It's going to be helpful for you. This is the most useful, probably, things that you can do. Right? You guys see that application? You guys see them, and that's useful stuff. So try to be useful. Now, these are applications that are starting to get into law of cosines. Okay? Law of cosines. Now, you say, why is it law of cosines? Well, let's read here. Right? They say two straight roads diverge at an angle of what? 75 degrees. Here's two straight roads. What's the angle? Angle is 75 degrees. So when they say that, they diverge. That means they're going in, there's straight lines that are not, they're diverging, going away from each other. Okay? So I just want to let you guys know the language associated with the picture. Because that's an important thing, don't you guys think? That's really important. So, okay, that kind of stuff takes study, in all honesty, I wasn't born knowing how to do word problems. I had to dig my way through it just like you guys. And then what do they say? Two cars leave at an intersection at 2 p.m. One travels what? 55 miles per hour. So I want you guys to know this here. 55. What's the other car traveling? It's traveling at a what? 72 miles per hour. How far are the cars apart at 4:30? Now, you guys remember this basic formula from beginning algebra? Distance equals rate times time. So which car do you think would be further away? Because your time, if you start at 2 and at 4:30, isn't that 2.5 hours later? Do you guys see what I'm saying? That's 2.5 hours later. That's T. So which car do you think is further, A or B? So that's going to be green. Is that right? And A is going to be what? This color. So distance is, what's the rate? 55 times 2.5. And then here the distance is going to be what? 72 times what? 2.5. Let's see what we get. So what color was this? I think this is what, gold. And what's 72 times the other? 180. Okay, you guys with me on this? So those are the values of A and what? And B. Those are distance questions. Okay, so you're going to have to get that. Distance is rate times time. Now, if I ask you guys a question again, what do you guys see here? This is what? Side angle what? Side. Side, angle, side. You have two sides, and that angle is between them. That's law of what? It's law of cosines. How do you deal with law of cosines to get this value over here, D? Anybody know? What is D? Let's write this down. Remember what I told you guys? If you have an angle opposite an unknown variable, side angle, side, law of cosines, this is what I remember. D squared will be, I don't even care which is A and B. I have no care. So what's D going to be approximately? What do you guys get? Okay, clear it out. Put the square root. Second square root, and what do you get? 137.5 squared plus 180 squared minus 2 times 137.5 times 180 times cosine of 75. And what do you get here? 196 point what? 2. And I guess that's miles, right? Okay. So now we're getting into what we call the what? Law of cosine applications. Finding distance between, 2 points when you have that angle right in the middle. So this is 196.2. And, I personally think in some ways those distance questions are a bit easier. Law of cosines is a bit easier. That's my personal feeling. So as you guys can see, you're going to see this situation again, side angle, side. And then this is another classic question, believe it or not. This is a question that we've asked, like when we interview for math instructors, we give a surprise question. The surprise question, ladies and gentlemen, is this one right here. I mean, it has been various years. Okay, now if we read this, what's the deal? A man walks toward a mountain along a flat surface and measures an angle of elevation to be 32 degrees. So here's what's going on in this example. Okay, here's the person, and it's walking. You know, they say a flat surface, it's not going up and down. In other words, it's a straight what? Line. So it's a horizontal. Does that make sense? So they never, this is the thing that I've always wondered about, or always kind of notated to myself. They never say, hey, there's a horizontal. Okay. That's what they mean, though. And then they have an angle of elevation. So the eyeball is here. And what does that angle of elevation measure? It says what? 32. And this is to the top of the mountain here, called a mountaintop, right? So, okay. And then he proceeds to walk how much? 200 meters. And then what does he do? He measures it again to be what? 38 degrees, an angle of elevation. And then you say, well, what's going on here? What do they want to know? How, what? How tall is that mountain? What's the height? $180 minus 38. What does that measure? That's 142 what? Degrees. Okay. Now don't forget over here, this is another what? 32 degrees. What is this called? Angle side what? Angle. So, what do you guys think? How do we approach it? Do you guys know how we approach this? I think, well, they didn't tell. They're going to say here. What do they say? How tall is the mountain? They notice this. They're going straight to that. So how do we deal with that? You know how we deal with it? Find. What do you guys want to find? And you can find that. Find the hypotenuse of that right triangle. You guys know what I'm saying? Call that D or call that X. It doesn't matter. So it's the same pattern we've seen by law of what? Sines. Yeah, I think I have 32, right? Call that D. We know this. We got to find this angle here, right? 180 minus 32 minus 142. Let's make sure that that is correct. So what do we get? What's that little angle? In that 174, is that 6 degrees? So sine of 32 degrees divided by D is equal to what? Sine 6 degrees divided by 200. What is D? 200 sine 32 divided by sine of 6. What do you get for D approximately? What do you think? 200 Sine of what? 32 divided by sine of 6. What do you guys get here? 1013.9. Is that right? Okay. Now this is just what? This is just D. Now that's a big deal. Okay, so 1013.9. You know what that does for you, ladies and gentlemen? You have a right triangle there, and we can find now the altitude, right? Because we have this angle being 32 degrees or 38 degrees right in here. If you guys remember, that was the angle of elevation for the second measurement. So do you guys notice that pattern? Law of sines followed by a right triangle. And then what's the definition again? You're going to say what? Sine 38 degrees. What does that give you? H over what? H over 10, 13 point what? 8. So H becomes our 0.9. Okay. We're almost done. Sine 38 degrees. What is H going to be approximately? .624 point what? 624.2 is the H. And there you go, 624.H. .2. I don't know, is that feet or what is this? Meters, right? Meters. And there you go, ladies and gentlemen. This is, I don't know how many of these we did today. How many did we do today? 5 or 6? I have no idea. How many did we do? Let me count. What are we going to do some more? I apologize, you can't hear me. Okay, sorry about that. So we were working on this law of sines, law of cosines application. I had to double check. We seem to have lost some audio here, at least in the room. Gonna check that really quick. Okay, anyway, we're going to get started here with that. I'll have to find that. That's kind of a little odd. You guys noticed you didn't hear much audio this morning, so it's here. It's going on out there. Anyway, okay, so let's get back to these very wonderful applications here. But I want you guys to note and recall the idea of angle of what? Elevation. And angle of, what's the other one? Depression, okay? What I'm going to do here is this. I'm going to put an eyeball. Now, in order to have that definition make any sense, you have to have a horizontal. Now, so here's your eye. In red, again, I'm going to remind you guys, this is a horizontal. And I'm going to put 2 objects now. Okay, one here and one over here. Okay? So if your eye is looking at something above a horizontal, okay, right in here, ladies and gentlemen, I'll call that alpha. Alpha is an angle of what? Elevation, okay? Just as a reminder. And it's always the angle, always, always, always between, those two lines, okay? It's always between those two lines. And then you say, well, what's this other one? Well, down here, you're going to have this beta. It's an angle of depression. That's beta. And that's an angle between a horizontal and an object. So it's always between. And they said the key word here is always going to be what? It's between those lines. Okay, so, we have that definition. I'm not going to write it all over again, but I want to remark here that, if it's below the horizontal, it's called an angle of depression. It's in green here. And if it's above, it's an angle of elevation in orange. So, we always want to remember that, okay? And that's a detail sometimes people overlook. So we're going to look over some good ideas here today, okay? One idea today also we're going to see is this idea of heading and bearing. You ever hear the phrase, we got to get our bearings about us? Anybody ever hear that before? You guys know what I mean? I don't even know what sound that is. I took this out. Oh, God, that's annoying. Okay, well, can't hear that stuff. I got you what's inside there. Whatever. So heading and bearing, I'm going to give you guys a compass here. You got north. Okay, here's a compass. South, and then we have east. We have west. You're heading and bearing, north, south, east, and west. So we're going to look at a phrase, like if I said to you, if they tell you here, north, theta, east, okay, northeast. That's going to be an angle, ladies and gentlemen, that you create that's right in here. Okay, so you start here. It's kind of like saying start north, and then you see the angle and head what? East. So this angle here is right in that position, okay? So that gives a direction. So heading and bearing gives you a direction. If they said to you, what about this? North, theta, west, again, you think about it this way, right? You start north, and then you go a particular angle, whatever that angle is, it's your direction, but you go in the west direction. So that's northwest. This is where you start. That's the direction where you end. And then similarly, if they said this, what about this situation, right? This will be start south, go a particular angle theta, so you're going this way for theta, like this. You start north, going east, start north, going west. This would be southwest, theta, and there you go. Okay, so I just want to kind of remark to you guys that we have this kind of heading and bearing concept. Okay, this is where you start. You say, so start south, head an angle theta, and you go east. There you go. So you're going south, theta, east. Again, it's where you what? You start, end. Start, end. So if I colorize this here, the starting point, right, is either north or south. So you'll have north or you have south. That's kind of where you start, okay? And then what comes next is the angle. So you're reading it left to right. So you have the angle. Start north, start south. And then you go the angle theta, and then you end where this gives you where the direction here. It's going to be, to the left there. So you start north, west, well, that's an angle to the left. Northeast, that's an angle to the right. But the important thing is it's, the theta's in the middle of those two letters. That's the angle they're referring, okay? So this is kind of a new way of thinking for some of these questions that you'll see in the future. And these questions have to do, in some ways, with navigation. You'll see some navigation questions worded differently, but some of the navigation questions are going to have this. Okay? All right. Now you say, well, what about this one? Well, this is called dead reckoning. And you go, oh my God, dead reckoning. Not quite sure what that means. I wish I had my sound. I kind of feel naked without the sound. You guys know what I mean? I'm like, God, what happened? I mean, I put that headphones in a bag and that little tip, something happened. So a pilot travels for 2.5 hours along a straight path, okay? So let's kind of read this phrase here, dead reckoning, whatever that even means. So a pilot is doing what? It's traveling for 2.5 hours along a path. Here's the path they're talking about, okay? And I guess I'm going to put a arrow here, all right? So how long is the pilot traveling? For 2.5 hours, right? And then what does it say? Then it makes a course correction. And you go, what? Makes a course correction heading 35 degrees. You go, oh, okay. So now it makes a course correction and it changes this direction. So they give you this kind of, right? And then this is a course correction, 35 degrees. Let me get this. Okay? And it's a course correction to the what? To the right. For an additional 2 hours. Okay? So the time here was 2.5 hours, and then the time here was an additional 2 hours. You guys okay with that? Right? You guys okay? You see what I'm saying here? Now it says that the plane has maintained a constant speed. Okay. Bless you. It has a constant speed of what? 600 miles per hour. Remember this formula here, right? Distance equals rate times time. So my rate is 600 times what? 2.5. What is that distance going to be? Well, we say, I don't know. We're going to get out our what? TI calculator. Oops. We have to wake up that TI. So what are you saying? 600? 1,200 plus 300. You're right. It's going to be what? 1,500 miles. Okay, you guys okay with that one? So we got 1,500 miles. And so here's we're going this way. And then 2 times, so this is 1,500, right? And so now we have distances, rate times time. And we're going to have 600 times 2. So that's an additional how many miles? 1,200 miles. So this distance is 1,200 miles, okay? Are you guys good with that one? All right. Now, what does this say? How far? The pilot is a she. So how far is she from the starting point? So in other words, they want to know what D is here. Is that right? They want to know what that distance is. So let's ask you here, what angle is that? Because if you notice, isn't this an angle? I'm sorry. What do we have? Side angle what? Side. Right, we have side angle side now. All right, you guys okay with that one? Side angle side. Now, how do we get that angle? Does anybody know? Isn't that a straight line? Didn't we talk about supplementary angles in the beginning? Right, that's why we did it. So 180 minus 35 is 1 what? Is that 145 degrees? So I'm going to get rid of that. 145 degrees. So ladies and gentlemen, good job. This sure enough is a what? It's a side angle side situation. If it's side angle side, what do we use? Is it law of sines or is it law of cosines? Law of cosines. Good. So I actually have the picture here, you know. So we're going to use law of cosines. Here's D. So what do we do with D here? This is going to be what? D squared. Remember, to get D, remember, you need this is law of cosines. You have side angle side. To get D, you get what? 1,500 squared plus what? 1,200 squared minus what? 2 times 1,500 times 1,200 times cosine of 145. D, 145. D now is the square root. Okay, so let's see what this is. We're going to go in the TI now, okay? So I think I woke it up. Remember, second, that's a square root. So you're going to have what? 1,500 what squared plus 1,200 squared minus 2 times 1,500 times 1,200 times cosine of 145. Double check. You guys okay with that? And what do you end up with here? 2,576 point what? 6 miles. Okay? All right. So again, a standard law of what? Cosines kind of questions. What do you guys think about this? Is that okay? Not too bad, but we do got to go through the language. Do got to go through the meaning of it, you know, and not too bad. So we're headed in the right direction. Okay. All right. Now, this is one of my favorite kinds of settings is navigation. Okay. Because when I was a kid, kind of like your guys' age, you know, when I was trying to decide what I wanted to do, you know, I wanted to be a pilot, right? I watched Top Gun. I said, oh, that's for me. I'm going to be a fighter pilot. Okay, you guys okay with that? Anyway, so there was motivation for me to learn about heading and bearing because that's used in navigation, you know, and I actually went into the Marine Corps. They don't just take anybody off the street. You have to apply. And I had to go through an application process to be a pilot. I went to Marine Officer Candidate School. And you had to take a lot of tests. I mean, you took the ASVAB, you took a flight aptitude test, and I forget the acronym for it, but that's really what it was. And these things were on that test. So you have to pass that test. So you got to know about it. So what I did back then is I went to the mall. It was the Montebello Town Center back then. There was a bookstore. They don't have bookstores anymore. Horrible. I went to the bookstore and they had all these different books on exams about which you know, different kind of exams of what you wanted to do. There were exams out there. Civil service exams, you know, if you wanted to be a male person, you got an exam for that, you know, all these exams. So I got this exam for this flight school kind of situation. And I studied it because I wanted to be a pilot. So I read it on my own, studied it on my own, and I got enough information that I passed that flight exam. That was another criteria I had to do to get into Marine OCS to be a pilot, right? So there is motivation that you guys can have to study, work hard. And, you know, those are some great things. Now, I didn't become a pilot because I have a depth perception problem. And I found out there because that, you know, unfortunately, I found out there. Depth perception. It's an issue. And it is true because I, you know, all these years, well, anyway, I don't have to give you the long story. I have a depth perception issue. So anyway, but I do remember the exercise and learning about navigation, and I was so excited about it. It's the stuff I'm teaching you guys. Read it left to right, not right to left. You know what I mean? Read it left to right. So when you say, what do you mean? 2 boats leave the same port. So this is where they're leaving, okay? This is where the port. So 2 boats are leaving this location. One travels at a speed of, I'm going to color that orange, 40 miles per hour in the direction of north, 50 degrees east. So remember, how does north 50 degrees work? Start at north, 50, but it's northeast. So this means that this angle And I use blue. I'm not used to using that. It means this angle is going to be what? 50 degrees. And the other travels what? 28 miles per hour in the direction of south, 80 degrees east. So you're going to go now south, and I can see already southeast, right? So they're going this direction. And that's supposed to be, let's see what I put. I see a typo. Do you guys see a typo? It's supposed to be 80. So let me double check something here because I wanted to match this picture. So change this to 70. So I have to change this here. Okay? So we're going to match the picture southeast here. Now remember, what's your distance formula? Distance is rate times time. So for the first distance, in orange, you're going 40. Like what's the time? Notice they're saying this. I'm sorry, I didn't finish this. It says how far apart, right? Are the two boats 3 hours later? So how far apart? You guys know what that means here? That means that this is the D. This is how far apart. Okay? So they want to find that distance. Now, 40 times 3 is 120. Is that right? That's this first one. And then in green here, distance is rate times time. So the rate's going to be 28 times 3. And you say, what's 28 times 3? 84. So what I found using our distance formula is this distance. And I found what? This distance. Important ideas here. And if you see this, you go, oh, is that why you have what? 120. Is that why you have over here 84? And then you say, but Mr. Judge, how come you have an interior angle here of 60? Like, how in the world do we get that angle of 60? Right. We have to go back here. What do we know from geometry here? 50 plus theta plus 70. Isn't that a straight line? So what I want you guys to remember here, this measures a straight line, doesn't it? I think it's straight. I'm at an angle. Sorry. So what does that mean? Let me remind you guys, right? When you have a straight line there, the sum of those angles. Yeah. Right? The sum has to be what? 180. Okay? So theta now plus 120 degrees is 180 degrees. So theta is going to be 180 minus what? 120. What is theta? 60 degrees. So this is where you get your what? 60-degree angle. So you get what? D squared is 120 squared plus 84 squared minus 2 times 120 times 84, cosine of what? 60. Okay. Remember, you have what? What do we say? Side angle side, law of what? Law of cosines. Okay, you guys see the deal? So that's why you worked on all those law of cosine homework questions. Right? You guys see what I'm saying? You want to work on that. Don't do it the night before. That's like if I went and I studied for that flight exam just the night before. I'm not going to pass that flight exam. Right? I had to study weeks before, months before the exam. All right, you guys get it? Do I sound like your parents, ladies and gentlemen? Exactly. I sound like mom and dad here. I sound like mom, dad, grandma, and grandpa together. Right? But you know what? Some students have told me, and this is heartbreaking too in some ways, that some people have said to me, you tell us things our parents should tell us. And I'm like, huh? And some kids, the reason I do it, because there are some kids out there in the world, their parents haven't told them this stuff. This might be the first time you hear it, So that's the sad reality. So anyway, so just bear with old man Judge here because, it might help. If it helps one person in the room, it was worth saying, right? So anyway. Just want to be consistent. Just looking at this and then being consistent. Remember, you got the angle opposite the known side there, or you got the angle there. These are opposites in blue. Okay. Anyway, let's punch this in the TI. And the reason I like using this, I just say the square root, right? Notice how nice that is. I just have to now 120 squared plus 84 squared minus 2 times 120 times 84 times what? Cosine of 60 degrees. D is 106.7 miles. $106.7 miles here, ladies and gentlemen. So here we go. And that's what we're looking for. Okay, you guys okay with that? Law of what? Cosines for this question. What do you guys think? Okay? Just some, warming up with the navigation question. Anybody have any questions on that one? Okay, you guys okay with that? We learned a quick little how to navigate or how to give an angle. And now we have another kind of question. These are good questions here. Another navigation. It's similar. Two boats leave the same port at the same time. Isn't that port P? One travels at a speed of 40 miles per hour. Distance is rate times time. In the direction of north 50 east. So we start where? North. We head east. There's that 50. So they're saying that this angle's 50. Okay. Now, like the last time, we're going to find a distance. We don't know that yet, but we're going to continue to read, right? So we just know that one boat is traveling 40 miles per hour in this direction. The other is traveling, so this is my 40 miles per hour. The other is traveling 28 miles per hour, and that direction is what? Due south. So we're going to have to talk about what that means. What does it mean to go due south? What do you guys think? What's due south? Going what? Down. Okay. So they're going to say, how far apart are the boats 3 hours later? This is going to be D again. Okay. This is D over here. I wanted to get a highlighter. How far apart? This is what they're asking now, 3 hours later. So we're going to have to get the distances, right? So this is 3 hours later because the time here is 3 hours. And so this is going to be 120. So I have 120 miles. The other distances rate times time is going to be 28 times 3. And that's going to be 84 miles. Okay, so take a look here because this is exactly what we did. Now notice, how am I going to get that angle? Because again, you're going to have what? Side, angle, side. It's going to be the law of cosines again. Because I got two known sides, and even though you say, but I don't have that angle between them, yes, you do. What do you guys know again? Is this a what? Is this a straight line? What do we remember from geometry about that? Even the first week, what do we remember? That 50 degrees and that missing angle are supplementary. Remember that? What does supplementary mean? The sum is 180, right? So 180 minus 50, isn't that going to be 130 degrees? There you go. So here you go. You got what? D, you got 130, and then you have what? The 120, you got the 84, and you're now in the law of what? Cosines mode for the side angle side situation. So let's do this up here. How's that? It looks like I have a weird worksheet. So law of cosines. Remember this. D squared equals, what does D squared equal? It doesn't matter if you put 120 first or you put 84 first. Is that right? So that'll be 2 times what? 120 times 84 times cosine of, what's the angle? 130 degrees. Now, you're going to have D being what? The square root of all that. Sorry, I think I got the wrong stuff. So what do you get here? 185.5, is that right? If you go out to the nearest tenths, there you go. So we found the distance that the boats are. It's 185.5. So, ladies and gentlemen, take a look here. What do you guys think? Pretty good kind of questions. That navigation stuff, yes, is a layer on top, but it's workable. Remember things like supplementary angles. That's it. Do you see what I'm saying? Just remember that supplementary angle, that all the angles you have there, if it forms a straight line, better equal 180. And that's kind of, again, we use it here, and we use it in the last example here. That's how we got the 60 degrees. So, just a little bit of geometry that you have to remember with that. And then these are some of my all-time favorite questions. Well, yeah, this is why a lot of times with this kind of questions, what are they going to do? They're going to draw a picture, kind of. Because even when you verbalize it, I mean, here's one of the benefits for drawing the picture. You guys want to know one of the benefits is? It takes time to draw these things. But, stop and think. Remember, and I encourage you guys to go into STEM. Trust me. I encourage you to get mom, dad, grandma, grandpa, talking again. So I encourage you guys to do that because it's meaningful. There's articles out there that are saying, they're going to look at a lot of things here in the state. If you read some of these articles, and I do, there's a lot going on. So one of which is, they may look at degrees, and they may decide that certain degrees don't have any value. And that's horrible, because I read an article. Maybe I can share it with you guys. It's horrible. And they go, how come, this article, 20% of all degrees obtained are these particular degrees, and they don't necessarily pay off, right? So they see that as a wasted kind of endeavor. You may be happy about that, or you may be angry about that. But that's what's going on, right? So, okay. The reason I'm bringing it up is because, back in the day, navigation was done this way, and it was done this way by hand. And now what they use are like computers. They use applications. And if you start to major in some of these, which I encourage, you may be asked one day to write a program that does some of the same things, not because it hasn't been done, but because they want you to learn how to apply what you know now in the world of what? Programming. So don't be fearful about it. You just learn the basics. You're learning the basics. And as you go along, you start adding the new added information. Like we did here with bearing and heading. We're adding a new layer. So this is kind of how it works. You're layering that knowledge so you don't get intimidated by the big picture. Okay, you guys see what I'm saying? So a fisherman leaves his home port and travels in the direction of what? North, 70 degrees east for 40 miles and reaches Egg Island. So when I first read this, I'm like, okay, I first have to know where is the what? Home port, for Christ's sake. All right, there's the home port. And what happened? You traveled in the direction of what? North, 70 degrees west. Here's northwest. And then where do I put the 70 degrees? Do you guys know? It goes where? Right in here. This is going to be what? 70 degrees. And I have to try to get it in there. Okay. See that? I'm going to put this little line, and it's important where I stop. Right? Isn't that the definition? The north, 70 degrees west. You guys okay with that? And then, okay, so where did the fisherman go? He reached Egg Island. Where's Egg Island at? Right over here. So what should this distance be? What are they saying that distance is? They didn't even tell you to compute it. They gave it to you. They're telling you it's what? 40 miles. So maybe I should just put this here in green and, there you go. That's the first part of the information. What do you guys think? Not too bad? It's actually easier in some ways. You don't have to do distances, rate times time. And then they say what? So the next day, he travels now where? Where does he travel? North, 65 degrees east. So you say, where is that? Well, north, east, 65. Here's what we know. That this should equal here. 65 degrees. Okay. And where is he going? To Forest Island. And that was for 60 miles. So again, they gave us some nice piece of information. Easy breezy lemon squeezy. All right. So I'm just matching the words with the picture. What do you guys think? Okay. Now what are they saying? Find the distance between the fisherman's home port and Forest Island. Oh, they're asking me for what? This distance is going to be what? D. Forest Port and what? Home Island. What's that distance? So what do you think you guys need now? Do you guys know what you need? Yeah, I'm gonna say I got news for you guys. This is gonna be a what? What kind of question is this gonna be? You guys know? It's gonna be a side angle side question. This is law of what again? Cosines. But you need that opposite angle here. How do you get that opposite angle there? This is a new wrinkle. So you're looking at Egg Island? Well, if you do that, you're going, can I find that angle? And you can, and that'll be 35 degrees because, and and this is what was notated. 25, sorry. Right, it's 25 degrees. Oh, you see a transversal here? So I think this is the claim here. Okay, I'm going to have to change colors. There's a horizontal line. Let's see if I could do 2 horizontal lines, okay? See if you guys can understand my point. Or understand the point. So this is going to be what? L1, L2. You guys okay with that? And then you say, oh, Mr. Judge, if I can do this, you have a what? What is this? This means we have 20 degrees here. Is that right? Which means what? So this portion's 20 degrees, and that means this portion's what? 20 degrees. Is that true? Because we're saying we have a transversal. 20 and 20. Is that right? You guys okay with that? Is this why Mr. Judge worked on what? Transversals? The answer is what? Yes. Maybe we should have people do the transversal homework again. And the straight angle homework. What do you guys think? So if you go down here, what did I do? Oh, I didn't even help you guys out at all. That Mr. Judge, he bailed on us. Oh, okay. He bailed. So I'm going to have to try to copy that picture. I'm going to try to do something here. Let's see if I try to copy that. See, I got to try to copy that triangle, right? Yeah, that doesn't even look right. Let me do this here. What goes in here? Do you guys know? It's not a great picture, but that's 45. Is that right? Say, how do we know it's 45? Because we found what? 20 plus 25 is 45. We're going to find D here. And then this was 60. And down here is what? 40. Is that right? So here's D. So it's not the best picture. Sorry. But I want you guys to notice, yes, we had to use 2 things here. Complementary angles and a transversal to get the 45 degree, because 25 and 20 is 45. And guess what, ladies and gentlemen? We are in that law of cosine mode because this is, again, what? Side angle side. Yes, outstanding. Okay, you guys okay with that? And, I'm getting all kinds of ideas. Jeez. Here we go. D squared is, what are we going to say? 40 squared plus what? Minus cosine of what? 45 degrees. Okay, so here we go. Second square root, what do we have here? 40 squared plus what? 60 squared minus 2 times 40 times 60 times cosine of what? 45. What do you get? 42.5. That's the distance they're looking for. And we don't have our sound today, at least not on external. Now be careful here. You guys ready for the next part? You might have said, "Boy, that was a tough one." It is. It is no doubt a tough one. But ladies and gentlemen, it is worth your time and energy. And I might, like I said, make another worksheet to try to get people to look at this. Okay? Let's look at the next question. This is what pilots have had to do, ladies and gentlemen, manually. Manually, historically. How do you get back? Stop and think. Or is being a pilot a pretty good job? I would think it is. It's pretty tough. At least it used to be. Because how do you get back home now? You know what I mean? You guys know what I'm saying? You're flying and I heard him very, like, how do you figure out how to get back home? Trigonometry. Thank God for trigonometry. Ain't that amazing? Like, how did the pilots figure out how to get back home? Because the next question is find the bearing. Oh my gosh. Here you go. Find the bearing from Forest Island back to Fisherman Port. From where? In other words, we're now going again, and I'm going to have to do a few things here. I'm going to get rid of some things because, like I said, it kind of gets a little what? Distracting. Okay? So stop and think about this. Find the what? The bearing from what? Forest Island to what? Home port. So remember this. How do you go from Forest Island to home port? They want the bearing. So notice if you were to navigate, what direction are you going? South, west. Is that true? Because you're trying to get to home port. Is that right? So you say, oh, we got to go south, theta, west. Now remember, what is theta here? Isn't theta this little angle? That's where the theta would be. And I know you can't see it too well. I can't write it in there. But ladies and gentlemen, how do we get theta now? Because we know we have to travel southwest to get home. So the question is, how do you get theta? That's the real issue. If you have theta, we can go home. You guys see what I'm saying? We know it's in the direction of southwest. To get to the home port from Forest Island, right? We're going this direction here. So does anybody know how to do that? Like, how do you get that angle? Well, get what? I'm thinking, which angle? I have an idea to do it. What I want you guys to tell me. Can I give you guys a hint? Okay, let me hear you guys. Okay, I don't want to be the one telling you guys all this because I want you guys to think about it, right? This is probably the hardest part, but not really. So tell me how you're thinking about this. Okay, tell me what angle for what location. Okay, so you're saying you want to find that whole angle. Yeah, it's Forest Island. I understand. Inside the yes, in the triangle around Forest Island. So everybody can understand, you want to find that angle. Now, let's say you find that angle. Let's say you call it alpha. Now what? Straight. Okay, you have a straight line. Okay. So you're trying to say we can use law of cosines to find this angle alpha. Is that true? But then I would say you probably need this angle. Is that right? Well, what angle is that? Is that 25 degrees? So, in other words, if this measures 20, I don't want to do that. If that measures 25, that means this measures what? 25. Is that true? Okay, you guys okay with that? So horizontals are a big, I'm sorry, this is a transversal. Is that true? Transversals are a big deal because what you're saying is this 25 and this 25 are the same because you created a transversal because this L1 and L2 are parallel. You guys with me on that? So what's our formula? Okay. The formula here is going to be, notice this, 25 plus alpha, right? 25 degrees plus alpha, I think plus what? Plus theta, what should that equal? That's a 90-degree angle, ladies and gentlemen. Okay? So, here, what we're saying, let me go back now. 25 plus alpha plus theta is a right what angle? And that's 90 degrees. Okay? So, what does that mean now? What is theta going to be? Is 90 degrees minus 25 degrees minus that alpha. Is that right? So 90 minus 25, what is that? 65 degrees minus the alpha. So this is all based on what? Finding that by law of what? Cosines. Is that true? So let's wrap our head around that approach because that looks good to me. I actually was, you know what I was thinking? I don't think I want to show it to you guys what I was thinking. But well, what do I know? Here's what kind of I was thinking. You see this here? Isn't that also theta? That's theta as well. Is that right? Just to give you guys an alternate approach. So if you found this angle, the home port angle, call that beta. Okay? You say, well, how do I get theta if I know beta? Well, if you know what this is, you can subtract. If you got beta, ladies and gentlemen, you guys see what I'm saying? How do we figure that out? Here's what I know. I know that 70 degrees, and we can't even see it, but 70 plus what? 70 degrees plus theta should be the beta angle. And so theta is going to be beta minus what? 70 degrees. Okay? So when I looked at this situation, and remember, beta is going to be by law of cosines again, you're going to get that angle. And all I'm saying to you is that 70 plus theta better be beta. Is that true? You guys see what I'm saying in that picture? So I was looking at a way to do it that way, because you could do a transversal with vertical parallel lines as well, and a third line. So this is another way. So I don't know. It doesn't matter to me. So let's find, if you want, let's do it your way, because you guys earned that, right? You say, what do you mean? This is the alpha angle, isn't it? So I'm going to erase this 42.5 now. So remember by law of cosines what you want to do. What do we want to do by law of cosines? Remember this? Here's what how I get a grip on it. Opposites. Is that right? Isn't that 40 squared equals what? 60 squared plus 42.5 squared minus 2 times 60 times what? 42.5 times the cosine of alpha. Okay? Remember, 40 and alpha. Is that true? We've been doing that to find angles. So what you want to do is ultimately solve for cosine theta. Now, how do you do that? 2 times 60 times 42.5 times cosine of alpha will be 60 squared plus 42.5 squared minus 40 squared. Cosine alpha, 60 squared, 42.5 squared minus 40 squared over 2 times 60 times 42.5. Okay? Right? So you guys okay with that? So we're going to now use our TI, and we're going to do the following. Remember, we're going to have to use what now? Inverse cosine. So we say inverse cosine of this whole thing. I'm going to get rid of this line just for clarity. So let's see, what do you guys get here? Let's try that out. Okay, remember what I did with the double parentheses? We have what? 60 squared plus what? 42.5 squared minus 2 times 60 times what? 42.5. Oh, I think I screwed up, sorry. Second, let's do it again. Inverse cosine, okay? Second parentheses, we have what? 60 squared plus what? What do we get? Is that 41 point what? 7? So double check, ladies and gentlemen. This is 41.7 degrees. Which is important to find because your real angle is going to be what? 65 degrees minus 41.7 degrees. Okay? So we're going to go to the TI. 65 minus 41.7. What do you end up with? Anybody know? $23.3 degrees. However, what would you say you really do? What's the real heading? What's the real answer? South what? I think it's southwest. Is that right? So here's your final answer. South, 23.3 degrees what? West. If you travel with this heading and bearing, right, you will get home. Going home is not so easy. So as you guys can see, I would say to you, trigonometry, law of sines, law of cosines, as you apply them, really has a lot of application in this real world, much more than what people will tell you. Much more. All right, you guys okay with that? Easy breezy lemon squeezy? See, I don't know if I would say easy breezy lemon squeezy. But when you first see this again, it is a challenge because look at all these colors. You go, my gosh, Mr. Judge, all those colors represent ideas. Anyway, did you guys see the homework I gave you guys in your book, by the way? Did you guys see, did we double check that, right?